You probably have already noticed that the speed of rotation is actually automatically calibrated when the animation is running, and it's based on the speed of your graphics card. How does this happen, and where do we calculate this frame per second rate? I'd like to show you in this video. So remember, we have the idle function, which I call animate, which is invoked when the GPU has done all its current work and has nothing else to do. So let's go to this function. It's right above the rendering. And what we do here, we create a variable and we count every frame, because it's inside the animate where we ask the GLOT library to start rendering the next frame. We also capture the start time when the program starts executing, and we also get the current time. And then here we measure how many seconds have elapsed since the program started. And you can see that these variables in our function body are declared static. So the static variables in the function body, or the local static variables, are initialized only once when the thread of execution passes their constructors the first time. Beyond that initialization, the variables remember their state between the function calls. So this animate function becomes a function with its own state. In this if statement, we compare the elapsed interval with previous interval using 1 second granularity. And as soon as we detect that the interval has increased, meaning that the new second just had elapsed, we set the frame per second rate to be our current rate. And then we immediately reset the frame counter back to 0 to continue measuring frame per second rate in the future. So we have now calculated the frame per second rate, and I keep it as a global variable. So it's declared right here. I set its initial value to some sort of number, but as soon as the first second of execution elapses, we get our frame per second rate according to the hardware on which we're running the application. So next, in the rendering function, we take the current rate that we have and we decide that we want the full circle of rotation to take 10 seconds. Okay, so full circle is 360 degrees. If frame per second rate was like 1 frame per second, then we would divide 360 by 10 seconds, and that would be the increment we need to give our rotation angle, theta, to make sure that we make one full rotation in 10 seconds. So that would be 36 degrees per second, 360 divided by 10. So if the frame per second rate increases, we must divide that 36 degrees by that FPS rate, so we can slow down the rotation in the correct proportion, and we can see that we're adding frame per second to the divisor of our formula. And of course, as we're starting with the degrees, we have to convert our angle increments to radians. And this way, our current FPS rate nicely controls the speed of animation. One optimization we could make would be not to measure frame per second rate all the time, like we do here continuously in our animation function, but rather maybe have a way to turn it on and off based on some other factors. But that's another story. You see, we can keep improving this indefinitely because this program tends to simulate a real world, so any concept from a real world could be added here the way you want to see it in your configuration of the project.